Hello and welcome to today's physics class where we'll talk about speed, velocity and acceleration. And under this topic, we will derive and solve questions relating to equation of uniformly accelerated motion, motion under gravity and motion in an inclined plane. And when we talk about speed, velocity and acceleration, it involves a body in a motion. And what is motion? Motion is the change of a position of a body with time, and it can be described in terms of speed, velocity, and acceleration. And what is speed? Say that speed is the distance traveled per unit time. Distance traveled per unit time. Distance is measured in meter, whilst time is measured in second. Therefore, the SI unit of speed is equal to meter per second. In our everyday lives, we use speed and velocity interchangeably, but in the study of motion, it is necessary to distinguish between speed and velocity. In speed, no direction is specified, while in velocity, it is necessary to specify direction. And we define speed in terms of displacement because displacement is the distance traveled in a specific direction. So, velocity is the rate of change of displacement with time, which is displacement over time. Displacement is measured in meter and time is measured in seconds. So, the SI unit of velocity and that of speed are the same. What is acceleration? Acceleration is the rate of change of velocity with time. Therefore, acceleration is the rate of change of velocity over time, which is v all over t. And this can also be written as v times 1 all over t, where velocity is in meter per second and time is in second times 1 all over seconds. We now have m times 1 give you m, which is the meter. S times s will give you s squared, which is in second square. Therefore, the SI unit of acceleration is equal to meter per second square. In this topic, speed, velocity, and acceleration, there are two major methods we use in calculation. One is by definition, and the second one is by graphical method. By definition, we have already gotten that speed is equal to distance over time, while that of velocity is displacement over time, and acceleration is equal to velocity over time. So let's look at the graphical method. A graphical method. Under this graphical method, we'll talk about displacement time graph and velocity time graph. Talk about displacement or distance time graph and velocity time graph. First of all, we'll talk about the displacement or distance time graph. Under this displacement or distance time graph, we assume that the vertical axis should represent the displacement, while the horizontal axis should represent time. And if we are asked to plot a graph of s against time, the slope will be a straight line. Let's assume here to be initial displacement and here to be final displacement. And here is initial time, which is 0, and here to be the final time. If you look at this displacement time graph now, we can find the initial displacement. From this displacement time graph, we can find 1, the initial displacement, which is S1. We can also find final displacement, which is S2. We can find the final time, We can also find the initial time, and we can find the velocity from this displacement time graph. And velocity is equal to the slope of the graph. We said that velocity is equal to the slope of the graph. That is, velocity, the slope, is equal to the slope of the graph, which is change in displacement over change in time. These are the parameters we can find using displacement time graph. So let's talk about velocity time graph. Velocity time graph. On velocity time graph, we have three motion or movement. We have uniform velocity or constant velocity. We have uniform acceleration or increase in velocity, and also have uniform deceleration. And what is uniform velocity? Uniform velocity can be defined as the velocity of a moving body whose velocity increases by equal amount in equal time interval, however small the time may be. Let's say the first movement, which is uniform or constant velocity, and it is represented on a velocity time graph as horizontal line. That is, velocity is constant along this line where acceleration is equals to 0. Why? Because the initial velocity and the final velocity have the same value. And we know that acceleration is equals to change in velocity over time, where the final velocity and the initial velocity are equal. All over time becomes 0 over time, which is 0. This is for uniform or constant velocity. And what is uniform acceleration? We said that uniform acceleration can be defined as the motion of an object whose velocity increases by equal amount in equal time interval. And if we are to represent the uniform acceleration on the velocity time graph, we have for uniform acceleration on the velocity diagram, V over t, the slope will represent the uniform acceleration. There's uniform acceleration where there is increase in velocity. And we have the last one, which is uniform deceleration or retardation. Uniform deceleration can be defined as the motion of an object whose velocity decreases in equal amount in equal time interval. And that can also be represented on the velocity diagram as uniform acceleration. The vertical axis, which is velocity, and the horizontal axis, which is time. The decrease in velocity from the highest to the lowest velocity represents deceleration or retardation, where acceleration is equal to negative acceleration. And if we are to draw this theory motion or movement, the uniform or constant velocity, the uniform acceleration, and uniform deceleration on a velocity diagram, we have here is the vertical axis, which is velocity, and the horizontal axis, which is time. And we said that increase in velocity or uniform acceleration is represented with slight line that is equal in velocity and equal in time. And for the horizontal line, which is the uniform or constant velocity, we have this. This one is uniform or constant velocity. Here is uniform acceleration or increase in speed, where this decrease from the highest to the lowest represents retardation or uniform deceleration. Deceleration or retardation when the acceleration is negative a. And from this velocity diagram, we have different parameters that we can find from it. The first is we can find final velocity, final velocity. We can also find initial velocity. We can find the slope of the graph, or we can find acceleration. Acceleration is equal to the slope of the graph. If we are to consider the slope of this uniform acceleration, we will find acceleration, where acceleration is change in the vertical velocity over the change in time. Let's say from here to here is t1, here to here is t2, and here is t3. Also find the acceleration along this line is equal to the slope of the graph, is equal to the slope, which is change in velocity over time, over change in time. From the slope, we can find acceleration. Also, we can also find uniform deceleration from this other slope. And fourthly, we can find distance traveled by the velocity or by the moving object. And the distance is equal to the area under the graph. Let's say if you are to find the distance from this initial to this velocity, we will consider the area under this graph, which is distance will now be equal, let's say distance, which is s, will now be equal to the area of this shape, and the area of this shape is a triangle. We have 1 all over 2 times the breadth times the height, which is height. We can also find the distance from this, the distance covered by the uniform or constant velocity, which is the area under this graph. Distance covered by the constant velocity, which is 5. Distance covered by the uniform velocity, will now be, if you look at the shape, it's a rectangle, will now be length times the breadth, which is length times the breadth. We can also find the distance covered by the uniform deceleration by considering the area under this graph. For distance covered by retardation, is equal to the shape of this retardation, which is half breadth times height. While from this velocity time graph also, we can find the total distance traveled by the moving object. The total distance traveled by the moving object, which is total distance will now be the area, the distance traveled by the uniform acceleration. Let's say it's S1, which is S1, plus the distance traveled by the uniform or constant velocity, let's say S2, which is S2, and the distance traveled by the uniform deceleration, let's say S3, now be plus S3. And this is the formula for finding the total distance traveled by the moving object. So from now, we'll calculate questions on the graphical method before we go into equation of motion. Question 1. A particle moves from displacement s naught, which is equal to 2 meter, to displacement s, which is 8 meter, in 4 seconds. Find its velocity and displacement. The first thing to do is to write out the given parameters and draw the displacement time graph. Let's see, from the given, we have initial displacement is equals to 2 meter. We have final displacement is equals to 8 meter in time, which is 4 seconds. We are asked to find the velocity and change in displacement or displacement. From here now, we can draw the displacement time graph. Let's say here is the vertical axis, which is displacement in meter, the horizontal axis, which is time in seconds. So the initial velocity is 2 meter. Yes, as here is 0, let's assume here to be 2 meter. Then the final displacement S2 is 8 meter. Let's take here to be 8 meter. In 4 seconds, press it to that 4 seconds. Let's assume here to be 4 seconds. So when you draw the line from this point of the final intersection to this initial, we have our displacement time graph. From here now, we can find velocity. I will know that velocity is equal to the slope of the graph. Let's say here's the slope, which is S1, S2, 0, and 4. From the slope, we can find that velocity is equal to change in S over change in time, which is equal to final displacement minus initial displacement all over the final time minus the initial time. And we know that the final displacement is 8 minus initial 2 all over 4 final time minus 0. Therefore, we have 6 over 4. And 6 divided by 4 is equals to 1 dot remainder 2. Add 0 to that will become 20. 20 divided by 4, we have 5. So velocity is 1.5 meter per second. And for us to find the displacement, is equals to final displacement minus initial displacement, which is 8 minus 2. We now have 6 meter. And that is for question 1. Let's go to question 2. The car travels from rest to 100 meters in 10 seconds. Find its velocity and acceleration. The given parameter given, we know that a car starts from rest, so initial displacement is equals to 0 since it started from rest. We have the final displacement to be 100 meter, and in 10 seconds, which is the final time, 10 seconds. So we should find the velocity and acceleration. First thing to do, we draw the displacement or distance time graph. We have the vertical axis, which is displacement, which is in meter, the horizontal axis in time, which is in second. From here, we have initial displacement to be 0, which is here. We have 0. We have the final displacement, which is, let's assume here to be final displacement, 100 in 10 seconds. Trace it to 10. Let's assume here to be 10 seconds. We draw from the point of intersection from the final to the initial. We have our displacement time graph. And from here, we can find our velocity. So we say that velocity is equal to the slope of displacement time graph. We now have velocity, which is equals to change in s over time, which is the final minus initial. We now have over t. We have is equals to 100 minus 0 all over the time, which is 10 seconds, which is 100 over 10. 0 cancel 0 becomes 10 meter per second. We have gotten our velocity. I will know that acceleration is velocity over time. So we have acceleration is equals to velocity all over time, which is velocity equals to 10 meters per second over the time, which is 10 seconds. We now have 10 cancel 10, now have 1 meter per second square. And that is for question 2. Let's go to question 3. A bus traveling at 60 km per hour accelerates uniformly at 5 meters per second square. Calculate its velocity after 2 minutes. From the given, we have the initial velocity u to be 60 km per hour. And we need to convert this 60 km per hour to meter per second. And we know that 1 kilometer is equals to 1000 meter. And also know that 1 hour is equals to 60 minutes, and 1 minute is equals to 60 seconds. So for us to convert hour to seconds, we now impute this 1 minute into this minute. We now have 1 hour is equals to 60 times this 60 seconds, which is 3600 seconds. So initial velocity will now be 60 times 1000 meter over the 1 hour, which is 1600 seconds. 0 will cancel 0, 0 will cancel 0, remain 10. Now be 60 times 10, we have 600, then over the 36. And what can divide both? We can say 3 divided 600, we have 200. 3 divide here, we have 12. 4 can divide again. 4 goes into 200, we have 50. And 4 going to 12, we have 3. So we now have 50 over 3 meter per second. And we are asked to find the final velocity at time equals to 2 minutes. And the time, which is 2 minutes, can also be converted to second, which is 2 times, we know that 1 minute is equals to 60 seconds. 60 seconds, now 120 seconds. And acceleration is given as 5 meter per second square. From here now, we can draw our velocity time graph. Let's say the vertical axis, which is velocity, and the horizontal axis, time. Here is 0, and let's assume here to be initial velocity, which is equals to 50 all over 3 meter per second, and let's assume here to be final velocity, that's what we are looking for, in 120 seconds. We draw this point of intersection to this place. We have our velocity time graph. I will know that velocity time graph, the slope of the velocity time graph is equal to acceleration. From here now, we can find our velocity using the slope of the graph. Let's find the slope of the graph. The slope A, acceleration, is equals to change in velocity over change in time. And we are given that acceleration is equals to 5, which is 5, is equals to the final velocity, which is v, minus the initial velocity, which is 50 over 3 all over time, which is 120 minus 0, we have 120. So here now we can find the velocity by cross multiplication. If we are to cross multiply, it becomes 120 times 5, 5 times 120 is equals to v minus 50 all over 3. We move this one to this side, it becomes v is equals to 5 times 120 plus 50 over 3, which is equals to 5 times 120, we have 600 plus 50 over 3. 3 times 600, we have 1,800 plus 50, we have 1,850 all over 3 becomes 1850 over 3. 18 divided by 3, we have 6. 5 divided by 3, we have 1. Remainder 2 becomes 20. 20 divided by 3, we have 6. Dot remainder 2 again, add 2 become 20. Now goes 6, 7, 6, 7. Therefore, velocity is equal to 616.67 meter per second. That is for this question. Question 4. When the brakes are applied to a moving car traveling at 60 km/h, it decelerates at uniform rate of 5 meters per second square. Calculate the time taken to reach a velocity of 36 km/h. The parameter given, we have initial velocity, which is equals to 60 km/h, which can be converted to meter per second by 60 times 1000 over 60 times 60. Now 0 cancel 0, 0 cancel 0. Because 60 times 10, we have 600. 6 times 6, we have 36. And what can divide both sides? We have 3 can divide it, 3 here. We have 200. 3 divide here, we have 12. 4 goes, we have 50. Then 4 goes here, we have 3. Becomes 50 over 3. 5 divided by 3, we have 1, remain 2. Carry the 2 to the remainder 2. Carry 2 to this 0 becomes 20. 20 divided by 3, we have 6. So remain 20 becomes 6 and 7 meter per second. We are also given the deceleration where acceleration will be negative. We have minus 5 meter per second square. We are asked to calculate the time taken for the velocity to reach a final velocity of 36. Let's say here is the final velocity, which is 36 km/h, which is 36 times 1000 over 3600. We have 10 meter per second. From here now, we can draw our velocity time graph. We know that the vertical axis is the velocity and the horizontal axis is the time. And here is 0. So the initial velocity is 16.610, which is higher than the final velocity. Let's assume here to be initial velocity, which is 16.67, and here to be the final velocity, which is 10 meter per second. Draw from the initial velocity to the final velocity at the final time t. And this is our velocity time graph. From the velocity time graph now, we can find our final time using the slope of the velocity time graph. I will know that the slope of the velocity time graph, A is equals to change in the velocity over change in time, which is equals to final minus initial velocity over the time. We know that acceleration is equals to minus 5 meter per second since it is retardation. So we have minus 5 is equals to the final velocity, which is 10, minus the initial velocity, which is 16.67, over the time, the final time, what you are looking for. When you cross multiply, we have minus 5t is equals to 10 minus 16.67. Therefore, minus 5t is equals to 10 minus 16, we have minus 6.67. To find t now, t will now be minus 6.67 over minus 5. Minus cancel minus. Will now be 6 divided by 5, we have 1, remainder 1. Take the 1 to this 6, becomes 16. 16 divided by 5, we have 3. Remainder 1. Take the 1 to this 7, we have 17. 17 divided by 5, we have 3. We have 3. Remainder 2. Take the 2 out, add 0, which is 20. 20 divided by 5, we have 4. So the final time is equals to 1.334 seconds. That is for question 4. Question 5. A car accelerates uniformly at a rate of 10 meters per second square from an initial velocity of 36 km per hour for 30 seconds. Find the distance covered during this period. From the question, we have uniform acceleration A is equals to 10 meters per second square, and the initial velocity u is equals to 36 km per hour, which is equals to 36 times 1000 over 3600. We have 10 meters per second, while the final time is equals to 30 seconds. We are asked to find the distance covered during this period. Let's say S. The first thing to do is to draw the velocity time graph. The vertical axis, which represents velocity, the horizontal axis, which represents time. And we know that uniform acceleration is equal to 10 meters. That's the initial velocity. Let's assume here to be the initial velocity, which is equal to 10 meters per second. And the final velocity, let's assume it to be here, v. Since v is not given, we will also find the final velocity. And the final time, which is 30 seconds, let's assume here to be 30 seconds. Now trace the final. So we draw this point of intersection to this initial. We have our velocity time graph. I will know that velocity time graph, the slope of the velocity time graph is equal to the acceleration. And acceleration is given. So we can use the slope of the velocity time graph to find this velocity before we find the total distance covered during this period. From the velocity time graph, we can find our slope, which is acceleration is equals to change in velocity over time. I know the final time is not given. Final minus initial. Initial is 10 meters per second. We have 10 meters per second over the final time, which is 30 seconds. Now 30 seconds. And acceleration is given as 10 meters per second. So acceleration becomes 10 is equals to v minus 10 over 30. When you cross multiply, becomes v minus 10 is equals to 30 times 10. We have 300. If you move this 10 to the other side, this negative change to positive. Now v is equals to 300 plus 10, we now have 310 meter per second. This is our final velocity. And from our previous explanation, we said that the area under this graph is equal to the distance covered during the motion. So we now have distance to be, if you look at this shape now, it's a trapezium, to be 1 all over 2 times the sum of parallel side times the height. As you look at this diagram now, these are the parallel side. So you add there, and here will be the height. Now be from here to here is 10, and from here to here is 310. Now be distance, which is 1 all over 2 bracket 10 plus 310 times the height, which is 30 minus 0. We have 30. 2 here we have 1, 2 here we have 15. So S will now be 10 plus 310 times 15. I know that 10 plus 310 will become 320 times 15. Therefore, 320 times 15, we have 4,800 meters, which can be approximate to 4.8 kilometer. Here's the answer for question 5. Please click on the subscription button to get the next video where we will talk about the equation of uniform acceleration using both the velocity time graph and equation of motion. I will also talk about the motion under gravity and motion in an inclined plane. Thank you.